Okay, so today we're actually going to talk about acids. So when we look at an acid basically is a compound, and it produces something called hydronium ions. And these are basically compounds that begin with an H. They can dissolve in water, so these are again acids. You can place them in water and they're easily dissolved and mixed in there. Hydronium, again, is a positive ion. That means it's written first. Okay? So when we look at some simple properties that we have of acids, the first one is sour taste. So think of this one with the Sour Patch candy, lemons. If you were to eat lemon, it would pucker up. It would have that sour taste to it. They can be corrosive to metals and as well react violently with metals. Not only do they react violently, but they can break metals down. They are an electrolyte. I am going to pull out a conductivity tester, and we will basically see if certain solutions can produce electricity. They also can burn the skin. You can see right here, these are some severe burns. In fact, acid burns are a little bit more severe than what we'll see with the bases. The pH scale of acids are from 0 to 6. And all acids, the compounds start with an H. Some common acids that we can find, we're going to start first of all with the very strong acids. Now, if you'll notice how these are all written, we'll start first of all with this one, hydrochloric acid. You might say, well, this is hydrogen chloride. Well, technically, in the formula unit that we had, yes, it is hydrogen chloride. But whenever you have a compound and it starts with H, odds are it will be an acid. So what they've done is they've named it hydrochloric acid. Look at this one. H is in front of the sulfate atom or compound. And actually, this compound is called sulfuric acid. And this one, NO3 nitrates, are actually a form of nitric acid, or some people say nitric acid. Another one is, let me go back, here we go, are the weaker acids. The first one up here is something you can get from the grocery store. You can get vinegars, but you also can purchase any of our fruits, citric fruits like oranges, grapefruits, lemons, limes. All of those are also weak acids. And the last one's kind of interesting. It's an eye wash right here. Boric acid, very mild, gentle, because you got to have it gentle on the eye. This boric acid is sort of mixed in. It's a powder blended in, and it forms this nice clear liquid that actually you can wash out your eyes. All right, so bases. What we have right here, this is a compound, and it produces hydroxide ions. And these are negative ions, therefore they are found at the end of a compound. They're the last part of a compound. So therefore your formula ends in OH, hydroxide, OH. Okay, some basic properties. First of all, let's look at that poor little girl's face right there. She must have eaten something and it tasted bitter and to her with that face. The other one, bases can be corrosive as well. They can break items down, and they also feel slippery, i.e. the detergents, your soaps, all of those are bases. They also, what's cool about this, they can dissolve fats and oils. And here we have Dawn dishwashing liquid. Well, Dawn made its heyday in the late 1980s when it was introduced during the Exxon Valdez. This is a big ship, and it was up near Alaska, and it was hauling away, carrying petroleum oil on there, on the tankers on the ship. Well, the ship actually had an accident, and all the oil entered the Exxon Valdez area, the little river or waterway there. And it got all over the birds and all over animals. And in order to dissolve it, they tried various different cleaning products. And finally, they tried Dawn, and it dissolved all the oils, which made it an easy recovery for the birds. Another one, it's an electrolyte just like acids. And again, we'll try base solutions and see if it can produce electricity with the conductivity tester. And also it burns the skin, but notice it's not as severe of a burn as it is with the acid. And also the pH scale is from 8 to 14. And lastly, the compound ends in OH. Now, I will say this, I didn't mention this earlier. The further away from 7, you actually have a more severe or a stronger either acid or base. So a base right here, 8 would be close to neutral, 7 is neutral, but 14 would actually be your stronger base. If you go the reverse with the acids, 0 would actually be the stronger acid than 6. 6 is close to 7. So as you get moved closer to 7, you're getting weaker or diluted. And as you move away, you're getting stronger. All right, some common bases. We'll start first of all with some strong ones. Lye soap, or this one with Drano, or sink cleaners. Basically, that is sodium hydroxide. Okay, the next one's potassium hydroxide, and then the last one up here is magnesium hydroxide, and that one right there are your laxatives that are listed up here. Also, cleaning ammonia is a weak one. Your deodorants is a base, and also any of your soaps or detergents, they are a base as well. So how do I determine if a compound is an acid or a base? First of all you got to do is look at the beginning. If it begins with an H, it's an acid. If it ends in an OH, it's a base. And if it's neither, it's going to be a salt that is produced. So acids, formula, they start with an H, bases end in OH. And if it doesn't begin with an H or doesn't end in an OH, odds are what we have right here, it'll probably be identified as a salt. So here we have these particular items, and you tell me if they're an acid or acid base, or is it a salt? Take a few minutes, raise your hand when you're done, and I will come around to check to see if you actually got this correct. Now, the next slide is dealing with neutralization. What if you mix an acid with a base? Okay, well, that's a neutralization. If you got a very strong acid and you want to dilute it or kind of weaken it, you actually mix a base with it. Okay, so that's what neutralization is, the process where an acid and a base are chemically combined. Now, their products, acid and base, are the reactants. The salt and the water are your products in this situation. So here we have again when you have a reaction between an acid and a base, it produces salt and water. This is a double replacement reaction. And what we have right here, here's a reaction. HCl, that's your acid. NaOH, that's your base. NaCl, that's sodium chloride, that's salt, table salt. And H2O, that's water. So when we look at this one, acid, base, salt, water. Okay? Our pH scale again, when you look at this, is used to determine if something is an acid or a base. If it goes from 0 to 14, that's basically the whole pH scale. Now let's break it down. Acids range over here from 0 to 6. This is the strongest, this is the weakest part of an acid. Then strong acids are going to be located down here, 0, 1, 2. And your bases are over here. They're from 8 to 14. 8 to 14. And your strong bases are going to be from 10 to 14. Notice there's a wider range for really strong bases. Okay? Now, in the middle right here, 7 is neutral. It's neutral. It's neither acid nor base. It's neutral. So if you have a really strong acid, you combine it with an equally strong base, you'll neutralize it and it will have a pH of 7. Water is neutral, therefore it has a pH of 7. So another way to determine if something is an acid or base is to use indicators. And these are little strips that we have. We're going to start first of all with the basic. All they do is determine if something is an acid or a base. So we have either blue paper, blue litmus paper, or red litmus paper. And you're actually going to dip both. And notice that we have down here, these ends down here were dipped. This was the actual color of the paper. This was the actual color of the paper. So when blue litmus paper, this one right here, is dipped into a solution and it turns red, it's going to be an acid. Okay? So blue turning red is an acid, but if you have pH, or if you have a litmus paper and it doesn't change, it's either neutral or it could be a base. You're really not conclusive on that. The only thing is blue turning red means you've got an acid. Now, if you take your red litmus paper, if red litmus paper right here turns blue, notice it's the opposite of the blue litmus paper. If red turns blue, then you've got a base. Think B blue, B for base. Okay? So let's repeat this again. If you have blue litmus paper and it turns red, this one is an acid. If you have red litmus paper and it turns blue, it is blue litmus paper. Another indicator that we're going to use in the lab today is pH paper. And pH paper basically can turn a wide variety of colors, and based on that, you got to determine its strength. Another one, the final one, is called phenolphthalein. Phenolphthalein is this real clear liquid, and we will play with that. And in an acid, it's going to stay clear. Even in neutral water, it will stay clear. But when you place phenolphthalein in a base, it will turn hot pink. Hot pink. So if you have a liquid and it turns hot pink, you got a base. If it's clear, it could be an acid or it could be neutral. And that is the end of our notes for today. Thank you.